Hi, my name is Brian Chung, and today we will be doing question 8 on page 174 from the textbook. So, before we start any of these questions, we must have a good understanding of what the first and second derivative means in this case. So, what is the first derivative? F prime of x, or the first derivative, models the rate of change of f of x. In other words, it is the velocity time graph of the original function. So let's begin by taking the first derivative of the original function. So right here, we have h of x equals to 0.01 x cubed minus 0.3 x squared plus 60. So to take the derivative of each term, we have to apply the power rule and the constant function rule in this case. So if we look at the first term, the leading coefficient is 0.01 and the power is 3. So according to the power rule, we have to multiply the leading coefficient with the degree. So in this case, we're multiplying 0.01 by 3. And then the degree of the variable will be 1 degree lower. So 1 degree lower, which is 3 minus 1, which is square. And we're going to do the same thing for the second term. 2 multiplied by negative 0.3, which is negative 0.6. And then lastly, the last term, 60, we have to apply the constant function rule. So the function states that if f of x equals to any constant value, then the derivative of it will be 0. And finally, we don't need to write the 0. So f prime of x equals to 0.03 x squared minus 0.6x. So what happens if the first derivative is greater than 0, less than 0, or equal to 0? So if f prime of x is greater than 0, then it means the function is increasing. And this means the slope of each x value will get greater as the x value increases. So it will look something like this. You see how the slope gets steeper and steeper as x approaches a greater number. If f prime of x is less than 0, then the function is decreasing. And the slope will get less steep as the x gets bigger. And when f prime of x equals to 0, then it's a turning point. At this point, the turning point, the function is neither increasing or decreasing. So that's why the velocity at the turning point equals to 0. And velocity equals to 0 is the same thing as saying f prime of x equals to 0, since the first derivative models the rate of change of the original function. Okay, so now we know what the first derivative represents. We are going to look at the second derivative. Now, to take the second derivative, we have to use the power rule again. Let's recall the power rule. So right here, we have f prime of x equals to 0.03 x squared minus 0.6x. So we are doing the same thing again. We are taking the degree multiplying by the leading coefficient. So in this case, 0.03 multiplied by 2x, and the degree is 1 degree lower, so it becomes 1. And then we're going to do the same thing here. So the leading coefficient is negative 0.6, and the degree is 1, so it's still negative 0.6. Since we have to take 1 degree lower, x to the power of 1 degree lower than that is x to the power of 0, which is just 1. So f prime of x is 0.06 x minus 0.6. So what does the second derivative represent? The second derivative of f double prime of x models the concavity of the original function and also the acceleration time graph. So when f prime of x is greater than 0, it is concave up and looks something like this. F double prime of x is less than 0, it's concave down. and looks something like this. And lastly, f double prime of x equal to 0. It is a point of inflection. So when you have a function decreasing or increasing, doesn't matter. This point right here in the middle, between the maximum and the minimum value, that is your point of inflection. So find the intervals of concavity for the given interval. So this question asks us for the concavity. Remember we mentioned how the second derivative models the concavity of the function. So let's find the second derivative of the original function. And previously, we conclude that the second derivative is f double prime of x equals to 0.06x minus 0.6. Let's just copy that down here. So the easiest way to find a concavity is just to graph this function. The x values that are below the x-axis, then it's concave down. And the x values that are above the x-axis is concave up. And when the x value equals to 0, that's the point of inflection. So to graph this, let's first put it into factor form. If we take the 0.06 out, this is left with x minus 10. So from this function, we know the x-intercept, it is at 10, and has a y-intercept at negative 0.6. We know this is an increasing function because the slope, or the n value here, it's positive. So the function will increase like this. So remember I said that the values that are above the x-axis, those are the interval that are concave up. There's a positive and negative. But remember the question only concerns about the interval between 0 and 22. So therefore, we can conclude that from the start of the ramp to 10 meters from the start of the ramp, it is concave down. And from 10 meters from the start of the ramp to 22 meters from the start of the ramp, it is concave up. Now the second question asks us for the steepest point on the ramp. The steepest point on the ramp means the maximum slope, which occurs at the point of inflection. And previously, from the second derivative test, we already figured out the point of inflection occurs at x equals to 10. But we are not done yet. We are finding a point. So if we find h of 10 is 40, so we can conclude that 10 meters away from the ramp and at the height of 40 meters is the steepest point. As we can see in this graph, between the interval over x equals to 0 and 22, we can identify the steepest point on the ramp from the graph, which is the point of inflection at the point 10, 40, between the two turning points at x equals to 0 and x equals to 20. We can see the concavity between x equal to 0 and the point of inflection is down, and the concavity between the point of inflection and x equals to 22 is up. So it proves my answer. A career that needs to study the concavity of a graph can be an economist. For an economist, a daily task is to study the business cycle where there is the expansion and the contraction. A concave down simply means going from expansion to contraction, and concave up means going from contraction to expansion. And the point of inflection in the business cycle graph means the steepest point during an expansion or contraction